Hey guys, today I wanted to cover a review on the Arizona Vortex that's located on Rescue 7. So at first I'm going to show you guys where it's located at. So our main kit that you see on the ground and that's set up is going to be located in the Stokes basket here on the left or right pull through. And it's just laid in there. Pull that out and it's ready to go. So some uses of the Vortex, guys. The main advantage of it is it's an elevated artificial high directional. And so some scenarios you might ask of why we need it or where we're going to use it. You could have a rappelling operation or just a rope operation that goes down the side of a building over a wall, right? So to make that transition with your hardware and ropes and to be able to come back up with a patient or a rescuer and not hit that wall, we elevate everything up with this device. Not only is it used in high angle, if you have a LARO operation where you have some mounds of dirt, rocks, grassy knolls ahead of you, and your ropes are going to end up in the dirt, we can elevate the ropes with this system as well. You can use it to do high lines, so you're going horizontally from one platform to another, and use our operation, debris over debris or anything like that. So for setting up the Vortex on a call, right, the first thing we want to do is figure out where our patient's located and line our system directly up with where we're going to deploy our ropes. And you want to be in approximate location to the patient. So we're going to simulate that we have a patient that's right here going down that we need to rappel down and get them to come back up. From there, once we determine that, we're going to start at our anchor points, which is in this scenario, the rescue. And then we're going to actually build our system back here away from the edge. So you build it, and then you bring it up on the guy line to the edge, and then you deploy it. So as far as assembling the system, the best way to do it is a minimum of 2 people. And what you do is you have the A-frame section flat on the ground, right? The head, you're building it, you're connecting it in flat on the ground, and then you're connecting these into the A-frame head. And then the same thing with your third leg back here. That's being built flat on the ground, connecting it in the gin pull head right here. And then one guy grabs this section, holds it, another guy grabs this section back here, and then you guys connect everything in there. So this kit is rated for a 600-pound 2-person load. And then if you were to pack this out and deploy it somewhere, all the components of the kit weigh approximately like 72 pounds. So they're located in these bags over here. There's inner and outer bags. There's pins. And then there is the feet and the heads. So you have the leg bags right here. You have all the pins, the 3/8 inch pins. And then you have a head bag and a bag for the feet and the hobble straps. So in this configuration, we have 2 outers and the inner on the front 2 legs. And then we have 3 outers and an inner on the back leg. So the manufacturer says no more than 3 outers. From there, the rest of the components, like I said, you have an A-frame head up here that serves as a connection point and that creates the A-frame. So you can connect in with multiple carabiners, pulleys, hardware. And then back here you have a gin pull head and they separate here. And so you can have this separate as a monopod or you can connect it in the easel leg configuration. And that's what this system is right here. It's the easel leg A-frame. From there, we have the older version of the Vortex. And so for ours, you have to have the inner legs that go into the heads. If you don't, you'll hit notches on the outer legs and it won't work. You'll have to swap it around. If you can see this on camera, when it starts to say caution, this is the last hole, right? That means you have one more hole coming up as you're sliding the outers over the inner. So it's just a little warning label to you. So this is the easel leg setup that you guys see here in front of you. As far as the pins go, the standard pins that come with the legs are 3/8 inch, and then the head pins on the A-frame portion of it are 1/2 inch pins. So this head has several connection points for hardware, 2 holes in the middle, big holes on the outside. As far as the pins go, as you can see, right, the front ones are all facing back towards the rescuers and essentially the safety member that's going to safety the device. And then on this leg, you see that all the heads are on one side of the legs. So that's kind of just a housekeeping thing. As you can see, we want the heads on the opposite side of our lines that are running by this leg so they don't catch on these ropes. From there, you obviously got your inners that we covered, and you got your outers as well. If you want to come over here on this version of the Vortex, you have these pins that seat into each other. So these are the pins I was talking about that you'll run into if you flip this the other way around and try to go into the heads of these of the system. There's no notches for the pins up there, so it won't work. As you come down, this is kind of the standard setup for the easel leg. 3 outers in the back, 2 outers in the front. That gives you some good height and then still lets you reach all the rigging. We're going to come down to the feet and kind of go over the feet a little bit. So there's two kinds of feet with this kit. There's the flat or the smooth surface foot. So what you have is a connection point for lashing the feet down, and then you have a ball and a receiver. And so the way that you want that loaded is with the forces and compression of the system pushing against this bracket and not vice versa, pushing out of the bracket per se. With that, there's a rubber pad on the underside, and then there is holes for staking the foot into the ground. So if it's too smooth, or if you're in dirt or something where you can stake it down to secure it, then there you have those options. The other foot that we had is called the Raptor foot, and this is used basically for everything else. So you can use it for rock, granite, dirt, soil, everything else pretty much. And so the unique features about this is you have multiple attachment points. You can sling stuff through the groove here, and then this little head right here is made out of titanium. So it's a triangular piece of titanium that's super strong, and that'll dig into cracks like you have on the ground here, very small cracks or grates. You don't want to use it on like catwalks or anything like that because it'll pierce through there. So you don't need a lot of purchase point, but that's enough to grab some spots. As long as you got to remember that this system, it operates in compression. So when you weight it, it wants to drive forces into the ground. You're not going to get a lot of skipping. So that's one of the key points with this system is it operates in compression, and so that helps you with dealing with slippage factor in addition to tying off the feet. So one thing about the older version is it doesn't operate in tension forces, right? So we don't want those forces operating on this system because it's not rated as strong for tensile strength. So from the feet, right, let's go over the orientation of them. So we went over the orientation of how this foot should be, which is that. And if you come to the front, these feet go a certain way. So it's not going to be turned the other way. It's going to be placed just like that with the tip in the groove. And that's enough to hold the front down into it. So when you place this system, near a ledge or a wall, you want these feet as close to the edge as you can. With that, when you're securing the system, besides using guy lines, there's 2 things you want to do. You see the orange straps that's hobbling the feet together. So that's preventing compression forces from going down and out on this front side, right? It's going to go down and out. And then on the back side, you're going to get forces that are going to push that leg out that way. And so that's what the orange straps are doing, or it's preventing kick out. And then with your extra slack here, you don't want to have that stuff just laying out everywhere because you don't want somebody that's going to trip on that and possibly lose their footing near an edge. You want to capture all that, clean it up, put it to one side. From there, in addition to doing the hobbling, what you want to do is you want to lash each footing to the ground if you can. And so the hobbling is different from securing the feet. You want to secure each foot separately to the ground. That way they don't move. So the hobbling prevents kick out, but the lashing of the feet prevents any movement in the feet. That's the most secure way to have it. So in this configuration, you can see from the side angle that we tilted the head out. And so that works great for somebody that's going straight down the edge, right? You can have the head out a little bit and the resultant stays in the footprint. So one of the key points with this system is understanding resultant forces and the forces of the load. And so basically what a resultant is where is the force through the pulley going to end up on the ground. And a good way to think about it is you take these two lines that are weighted and you bisect the middle of them, which is around here. That's your resultant force. So it's an imaginary force that's driving into the ground. If you were to take a laser, you would go from the middle of this pulley and you would end up in the middle of that footprint. So with this system, you have to have resultant forces that stay in the footprint of whatever you have. So when you're setting a Vortex system up and you want to check the resultant, right? So you weight the system and you predict where the rescuer is going to end up going. So if he's going straight over the edge, perfect. We got straight over the edge, resultants remaining in there. Now, if you got a LARO or a tension diagonal or a highline system, right, the rope is going to be changing, right? So let's say I'm walking out. You can see the pulley right here move forward. Now your resultant's changing. It's coming forward close to these feet. And if you come all the way out, now you're approaching the front of these feet. So if you get outside this footprint in the front of these feet, that's when you get into dangerous territory and you have to have guy lines. So a little bit about guidelines on this. Technically, in this setup with somebody over the edge, right, we got compression from the weight driving the feet in the ground. This thing's not going to move. Now, that doesn't prevent the normal reaction of an unexperienced rescuer that's sitting here and is scared and grabbing these, and they could collapse the system down. So I like to have people put at least one guy line in on the easel leg configuration, which is this red line right here. So it serves a couple different purposes, right? If you're getting near the edge when you're deploying this, right? Somebody trips, they let go of this thing, we don't want it falling over the edge and losing our equipment, but also it acts as a guy line in case somebody grabs the legs or whatnot. So the rule of thumb with guy lines, when you look at guy lines and how you measure the angles, it's the angle from here to the leg. So that angle you want to be a minimum of 30 to 45 degrees and more than that if possible. So when you're deploying your guy lines, right, you got to simulate where this is at and then figure out where your anchor is going to be to establish that. So we got our main line. We're simulating the blue line as our main line. Here we use 2 rope systems on our rope operations, one for main, one for belay. And so the rule of thumb with belay, or safety line, is you want to separate anchor and separate from the Arizona Vortex. And so typically what we will do is we'll run another safety line, right? We'll take an Aztec kit, connect it in here, adjust it all the way to the ground, connect into the belay line. But that belay line is literally touching the ground. So if this collapses, they're not going to fall on their safety line. So when a rescuer comes in, right, he's ready to be deployed, we're going to run our ropes, or one rope through here, come back to him and connect into him. And then the safety line is going to come up, connect into him. And then we're going to raise that Vortex up, or the Aztec kit up, right, on the safety line. And he's going to come over the edge. He goes down. Once his head goes down past the feet, then we lower that Aztec kit that's on that safety line all the way to the ground. And that way it's taking up any of that slack in case he has a fall.